since that came up as a question. So the router will take the subnet mask, it will do a binary end with the subnet mask, and it will zero out the host part of the IP address. And then it looks in its table for the bits that are left, which is the network part, and compares it with whatever is reading in its routing table. If it matches any of the entries, it forwards it on that network interface. So the table has two parts, address and a network interface that matches it. So, in other words, for this address, forward the packet on that interface. So the router is a machine that has a bunch of network interfaces. Each is part of a different network. And in the table, it has address and interface pair. So let's say this is a machine, host 1, which wants to send a packet to a machine, host 2. The packet starts by being forwarded to the nearest router, A. A looks up in its table and sees which direction this packet should go to in order to reach the destination. So in this case, we have two home machines and a network in between. What is in the oval is the internet service provider's equipment. So these routers and the links that connect them are owned by the internet service provider. This router is a private router for this guy's local area network. It's not part of the internet service providers. So the router has a table called the routing table, which has two things. First, it has address for the destination machine, and then it has a network interface card or line on which it should forward the packet. So all that it does, it looks in its table and forwards the packet to the next router. So this is a table, routing table for A. The packet is supposed to go to F. So it looks here in its table, it says packet supposed to go to F, forwarded on line C. So A will pick up the packet, forward it to line C. So C is the next router that will get it. It will briefly store the packet, examine it for errors, so it's going to check this header checksum. If everything is okay, it will look in its table and say the packet is going to F. So forward it to for C's table, the packet is going to F. Forward it to E. So take the packet, forward it to E. E looks in its routing table, packet is going to F, which is myself, so I'm sending it to one of the hosts in my local network. Now, all this packet was split into 4 pieces, and all of them went through this route. A, C, E, F. Except for the last one. The last one picked up a different path.
So literally every router has a map of every IP to every IP, or is it like sections of IP to sections of IPs? Because like that'd be massive if it was every day.
Only has a table for the routers that are its neighbors. And if it doesn't know what to do, if the packet is not going to any of the neighbors, it has a default line. And this default line is connected to one of these huge, fast, like data center type of routers that have a special hardware designed to just do this. Subnet mask, match it, forward it. And they have then the whole information for the whole internet. So if these guys don't know what to do, they send it to default router that supposedly knows what to do with it. But most of the routers don't have the complete information for the entire internet because that's humongous and they don't need to be maintaining such large tables. So the other packet, the last packet took a different route. Why would it do something like that? I mean, 120 went on the same path, and all of a sudden, packet number 4 decided to take a different route.
Shouldn't matter if it goes like the other one, unless they bunch fail in a row, and then it doesn't matter.
Something failed, right? Something happened here. So this is the beauty of these routing algorithms, is that these tables here are not static. So the routers have information about their neighbors all the time. Each neighbor will send its information to the rest of the neighbors and tell if it's alive, if it has congestion on certain lines, or what's going on with the network. And that happens every couple of seconds. And so these tables are refreshed all the time. And so if something happened to one of the nearing routers, let's say C all of a sudden said, I am overwhelmed. I got a denial of service attack, or I have a congestion, I cannot handle all the packets that came to me, or I'm dead. I am physically destroyed or something. And so all of a sudden it sends that to all of its neighbors. And so A learned about it and say C is no longer the best route to take. So go through D and updated its table. And when the last piece came, he went on a different route.